So far in the previous videos, we've covered 4 of the 7 indeterminate forms that were shown in the very first page of these notes. And all of the remaining indeterminate forms were indeterminate forms that looked like either 1 to the infinity, 0 to the 0, or infinity to the 0. And so we refer to these as indeterminate powers, since they deal with having bases raised to a power. So thus far we haven't really addressed any of these in the previous examples. So what we're going to try to take a look at here is what happens when I have a limit with a function raised to the power of another function, and that it ultimately produces one of these indeterminate forms or indeterminate powers, like a 1 to the infinity, 0 to the 0, or an infinite to the 0. How do I deal with something like this? Well, I'm going to go ahead and I'm going to introduce some new notation here to help us try to tackle this. So I'll state here that we introduce the notation exp of f of x. So the new notation is this exp of something. And when we write that, that's really just going to be an alternative way of writing e raised to the power of f of x. Now, this is a very, very common notation in classes like differential equations, but it's also fairly common within Calc 1 for specifically dealing with indeterminate powers. And you'll see a little bit more as to why we're going to sometimes prefer to use this exp of f of x form rather than just simply writing e to the power of f of x. So I'll start here then by seeing how we are going to deal with this limit by just noting that really the key to finding limits of this form, that is, when I have an indeterminate power, I have a function raised to the power of another function, is to notice the following. So what we would need to notice is that the function f of x raised to the function of g of x could be slowly rewritten using the following. First off, I could take all of this and I could turn it into exp of the natural log of f of x to the g of x. Now, when you look at this, this can obviously be a little bit confusing, so let me write it in kind of this alternative notation. Really what we're saying is that we can rewrite this as e to the power of the natural log of our function. Remember that e to the x and the natural log of x are inverse functions, and so they will undo each other and they will just leave us back with the original functions. Now what you can start to see in this blue form is why I might actually care or start to care about using this exp form, is that I can see that I have e raised to a power, and then within this power there are other powers. And later on in here there will also be other fractions, and that can start to make this, like trying to write things small enough to fit inside the power, really kind of complicated. So let's go ahead and see why exactly writing things in this form can be so useful. Well, one of the reasons why is that I can make use of natural log properties. Notice here I have the natural log of something to a power, and so I can take that power down and pull it in front of that natural log function. So this would look like exp of g of x times the natural log of f of x. Again, in blue form, that would look like e to the power of g of x times the natural log of f of x. And you might still be thinking like, well, Kyle, why is this useful? And the reason that this is useful is because once I'm to this form, I might be able again to slowly get my limit. The limit that I have of this would now be applied to here, and I might slowly be able to work out of one of these indeterminate forms into an indeterminate form of 0 over 0 or an infinity over an infinity. So to kind of see how this is going to work, let's take a look here at example number 7, where we're going to have an actual example of this sort of a limit, where I have the limit as x approaches a number of a function raised to another function. Here I have some pretty simple functions, and just that I have x to the power x, limit as x approaches 0. So in order to do this, I should first note that the form that I have for my limit is 0 to the power 0. And that, again, is not something that I can actually compute. And so I'm going to look to try to find a way to rewrite this. So let's start by using this exponential notation here to find an easy way to do this. So start by saying, note that the limit as x approaches 0 from the right of the x to the x is equivalent to doing a limit as x approaches 0 from the right of e raised to the power of the natural log of x to the x. So I'm kind of making this step here, e to the natural log of x to the x. But of course, I can rewrite that using my properties of logarithms to look like the limit of e to the power of x times natural log of x. Now, this is really helpful because notice that if I'm kind of at this step right here, I have my x, I have times my natural log of the other function, and all of this is raised to the power of e. I should be able to notice that, again, since e to the x is a continuous function, I can take my limit and I can bypass that exp, and I can move my limit to kind of just exist as a limit on the power. Now really quickly here, I'll write again in blue what I've really stated here. We now have e raised to the power of the limit of x times the natural log of x. And so now I've been able to rewrite what I used to have, which was a limit of x to the x, which is a really messy form, and I've been able to kind of take it into a form now where I have e to a limit, but this limit here, notice, is of the form 0 times negative infinity. So I still don't have one of my good indeterminate forms, but I'm at least out of these difficult power indeterminate forms, these indeterminate powers. And even more interestingly, you'll notice that we've tackled this exact limit before. We've dealt with this limit. In fact, if we were to go and take a look back here in the previous page, this is exactly the limit that we saw in example number 4. We had a limit as x approached 0 from the right of x times natural log of x. And the way that we tackled a question like this was to kind of do an quote-unquote unsimplification, right, where we took this value of x and we said, well, I don't have a fraction yet, but maybe I can force a fraction in here and get a nice indeterminate form. So I'm going to go ahead and kind of almost repeat at this point almost everything that we have back in example 4 on this example here. So let's see what we come up with. I could rewrite this then as e raised to the power of my limit, but I'm going to rewrite my limit with 1 over x. Then I can go ahead and note that I'm going to be in the form for my limit of negative infinity over infinity, and so I have a good opportunity now to use L'Hopital's rule. So if I use L'Hopital's rule, oops, forgot my exp, I'm going to see that I'm going to have exp, so e to the power of the limit as x approaches 0 from the right, and I'm going to have 1 over x in the top and a negative 1 over x squared in the denominator. I then can go ahead and do some simple algebra. This is going to be exp, limit, x approaches 0 from the right, and again here I'm just going to end up with negative x. So overall this is just going to end up being exp, so x, or e raised to the power of, and I'll just evaluate my limit. And my limit here is 0. And so I end up with e to the power of 0. But of course, e to the power of 0 is 1. And if I look at everything now that I've connected, I've been able to say that my limit of my limit of x to the power of x is really just equal to 1 as x approaches 0 from the right. Now, this again can be a little bit confusing and intimidating at first because there's a lot going on here. And again, it may still seem a bit strange to you that I'm even bothering to use this exp notation. This may seem like it's just kind of cluttering and muddying up the work and the problem. And if you don't want to use it, you're more than welcome to avoid it. But I'll just quickly highlight one last time. Notice how annoying this step would be to write if I was going to write it in my classic e raised to a power form. I'm going to have to write things really, really tiny so that way I can make sure that as I reread this, I recognize that everything from the limit on is actually in the power of the value e. This is part of the reason why we like this exp notation, is that it allows me to just write all of this in kind of full font, right? Like I get to make that as big as I need, so that way I can think about what's going on, and I just recognize that I have all the stuff on the inside of these parentheses is just in the power of e. So again, if you don't want to use this notation, that's totally fine. It's not required, but it's just a helpful way to try to think through what's going on without getting your page too cluttered.